Right, first of all, the usual sort of health warning. This is very much a personal presentation, so there's no commitment or anything else from UK government in what I'm going to say, or whether they agree with what I'm going to say. So I don't know how busy this slide is for you, probably very busy, but essentially Dstl, we have been part of the Ministry of Defence since the early start of last century through various different names, etc. Currently, we are an executive agency of the Ministry of Defence, and our name Defence Science Technology Laboratory started in 2001, where we partitioned part of the then DERA and the other research labs into a private industry part, which is kinetic essentially, and the government part, which is Defence Science and Technology. So we're enabling executive function for the Ministry of Defence. And the only thing I've highlighted, you can see the overall structure all the way to the Secretary of State, but is the Chief Scientific Advisor for the MOD, which is Dame Angela McLean, you may have seen during some of the COVID, government announcements, etc., and TV things they were showing. But essentially, the reason I'm pointing out the Chief Scientific Advisor is she sets the MOD S&T strategy for the future. And as you will see in the next slide, this is the strategy that was set in 2020 for science and technology, and they identified 5 key challenge areas that defence and security must address as part of that strategy. And you can read the 5 there. The only one I want to point out is the one about multi-domain command control, communications and computers. And this also includes the integration of the system of systems you have to deploy in operation. That's a key enabler for the rest of the functions. And the other ones that you presumably read already, the freedom of maneuver and so forth. And another key focus is that the generation after next. So in the MOD, we have 2 different stances. One is next generation, which is the systems that we're currently using, which we want to update. And then there's a generation after next, which is the new capability that we need to bring in. And that's a key part of our strategy, because if any of you have worked within the defence and security area, some of our systems are there for 10, 15, 20, 30, 40 years and longer. So getting technology insertion is always a challenge for us. So we're looking at that a generation after next. So in terms of Defence Science and Technology Laboratory itself, we have approaching 4,500 staff across 4 of our sites, and about 60% of our research funding and government funding is actually delivered by industry. So this is a really key thing for us to draw that capability that exists elsewhere. And our turnover is approaching around £1 billion a year at the moment. So you will see in the examples I show you, but we deliver high impact science and technology for UK's defence, security, as well as prosperity. This prosperity part is about the UK economy growing as part of our investment in defence and security by getting other organisations working with us, as well as supporting some who don't normally work in the defence area. So for our own portfolio within the organisation, and this probably gives you a very good example of how our work is distributed. So essentially 7% roughly of our work is operational support. And we've been doing that, as I said, at the beginning of last century. It's carried on. We've been involved in every operation Ministry of Defence has been involved in since then. Recent ones obviously being Afghanistan. And we're also involved in terms of operational support in our local challenges that we have within the nation itself. So examples were the Parson Green bomber. Before that, we had the London bombings that we're very closely involved in. We had the Novichok incident in Salisbury, which really occupied quite a lot of our capability, as well as looking at the Syrian weapons of mass destruction and so forth. And in addition, we have that specialist advice and services that we provide not only to the Ministry of Defence, but also to the Home Office. We now have as part of our organisation, the Home Office Police Scientific branch working closely with us. And as part of that specialist advice and services, we look at the next generation of platforms etc., the requirement specification, the testing, evaluation of some of the bids that come in. And that is part of our requirements and evaluation work as well, which occupies a third, and the F-35 being an example that you can see at the bottom left. And also we've set up the cyber task force in the UK. So we have quite a lot of commitment in cyber, and I'll give you an idea of the quantum work that we do. And finally, about just under half our work is about research, not only us, but delivering capability from others within the UK and internationally as well. One thing I shouldn't forget is in terms of the economy, this is the sort of estimate that we've made in terms of what we've generated in the UK economy as part of our work in recent years. And also we have intellectual property as well. And what we've done in the Ministry of Defence is we own a company called Plowshare, which is sole purpose is take our intellectual property and then have it exploited in the civil domain. Some of you may have seen some of the materials you put on, I don't know, trailers and so forth, which are hydrophobic, if I got that correct. In other words, water repellent. That is the technology that we developed for military, which has gone into the civil domain. But there are many other examples. And if you search for Plowshare on the internet, you'll find the work that they're doing. And before I forget, the key thing is the sovereign capability. So we do in Dstl work ourselves, which is absolutely essential for maintaining that sovereign capability within government. So in terms of our customers, this is a sample of the customers that we have. The research from the Chief Scientific Advisor, the part of the pie to your upper left is about approaching £500 million. But then we provide wider government support. I mentioned the Home Office earlier. We also support DEFRA as well. Obviously, there are services within the Ministry of Defence, all of them, DNS, Strategic Command, and so forth. And so this gives you just an example of the distribution of our capabilities in defence and security. So when I talked about working with others, and I mentioned that 60% of our work is deliberately out there, primarily with industry, with academia as well. And that is, we recognise that the S&T capabilities are advancing at such a rapid rate, globally as well as nationally. We really need to draw on skills from others. So examples of work that we do with others, industry, I mentioned the F-35 earlier on. These are the various companies that we've contracted who work with us on that particular program, as well as with DNS. And we work with academia. This is just a sample of universities that we work with. And then finally, we have that really close international collaboration. We have some arrangements with around 40 nations. I think it's over now, but it's really working with about 40 nations. But our primary strategic alliance is obviously with the US and the Five Eyes partners that we have, because we work with very sensitive areas with them. And we are one of the largest contributors to that international collaboration, which has been going on for many, many years. So that's a key bit for us. The other one, which is really critically important at the moment, is NATO, which we work very closely with as well, because we recognize any operations that we are dealing with now or in the future always involve some of our closest allies. So the capability to interoperate with them is absolutely critical, as well as influencing their forward thinking. So in terms of our strategic capabilities, we deliberately partitioned ourselves into these 22 capability areas. I don't know how clearly you can read these at the back at all. Is that okay? And they're really delivered by 9 divisions within Dstl. So these are the divisions I've named here. And from the C4 systems group that Paul, myself, Kiran are from, then the yellow bordered areas are what the division itself delivers, the 8 capability areas. We major on 2 of those capability areas, one being information systems, the other one being comms and networks, communications and networks. And those 2 capability areas are key enablers for most of the other capabilities that you see on there. It's very much like having your home computer systems, your networks and so forth. Without them, you wouldn't be able to do many of the other capability functions perhaps you do at home. So these are critical enablers for the other capabilities. And that is why the group teams in C4 Systems Group really are focused towards delivering capabilities into those specific areas. So we have comms networks and barriers as one example, the integration of C4 systems, another, command control and information, another team, and finally the information assurance security. We've got to ensure that whatever the information systems are, the comms and networks overall have to be secure, have to be assured, have to be resilient and so forth. So that is the sort of raison d'etre for the group. So in terms of the division, just numbers again, quickly. So we have 800 staff. We're trying to recruit like mad at the moment. And the STEM skills and capabilities that are available in the UK and elsewhere are in short supply simply because there's so much demand from some of the new industries, some of the growing high-tech industries, and that's a big challenge. And I think this is one of the areas we would like to talk, obviously, to yourselves here. And again, the delivery by externals, £175 million has been delivered in terms of S&T already, but 100 million of that is really being delivered from industry. And the key thing I want to know, just a couple of things. I'll talk more about the program. So what we do is the delivery of the capabilities is done through programs, S&T programs. They're listed there. And the one that the C4 Systems Group looks after is the Comms and Network program. And also another one not shown here is the Information Systems one as well. And what we're trying to do is also look at I mentioned the generation after next. So this sub-threshold is capability areas where we in the UK recognize that there's an urgent need to actually fill that capability shortfall, if you like. In other words, to have something on the shelf for the future. So we have a targeted investment which started this financial year to deliberately look at that generation after next capability that I mentioned earlier on. And some of the areas would be quantum, cyber, and the space science area as well. So coming to one of the programs, and this is going to be a fairly busy slides, but I apologize in advance for that. But what I'm trying to bring out for you is that if we're looking after the overall infrastructure for the communications and the networks for all our military operations, that is a huge challenge. So this program, the Communication Networking, the Networks program, is really trying to look at not only the next generation, but the generation after next capabilities that can support defense and security in that endeavor. And the names there are deliberate, so if people want to make contact with individuals, they're named in the slides that follow, and you're more than welcome to talk to them directly if you so wish. So the strategic context, I don't think this needs much explanation to people around the table, but the key one I want to draw out is that S&T is really an international competitive area. We do not have in the UK or the US that privilege that perhaps we may have had 80, 90 years ago, where we had enough military investment to sustain that advantage over our competitors. Our competitors now, as well as the civil market, have huge amount of investment in science and technology, and they recognize the importance of science and technology to give them that winning edge when it comes to defense and security. And the other thing is seeing some of these things in conflicts already. We need to have that resilience that science and technology can provide. Examples, COVID-19, I think that was a huge success for science and technology in getting that development of vaccines out very, very quickly. We have challenges at the moment about climate change, how do you store energy, and so forth. And also associated with the international competition and climate change is supply chain. We can no longer assure ourselves that the components that we want, which are, in the areas I work in, ICT, are mainly from Asia, which we put into our systems, etc. We can no longer guarantee that supply, nor can we guarantee that the materials that are used for that supply are not now being dominated by other countries to the extent where we can't actually get the fundamental materials that are needed to make some of those components. And those are really big threats, and we need science and technology really try to understand how we mitigate them. And as I mentioned earlier on, the government has this economy, growing the economy agenda, and therefore S&T is an essential part of that. And the buzzwords are to do better and be better, and that's the thing that the government is trying to push forward. So this is going to be even more difficult for you guys to see in the room, but all I'm trying to show you is, people say within the civil world, why is it hard to communicate in the military operations? I sit at home, I've got my internet, I've got my wireless, etc. I can download apps, I can look at services, I can do everything worldwide just on my phone. Why can't you do the same? Well, hopefully this gives you an idea of the complexity that we're working with in terms of all our military operations, undersea, sea, land, air, and space as well. And we don't have the good fortune of a huge infrastructure that is always available to us. When you plug your computer at home or using your mobile phone, we don't have that luxury at all. Sorry?
No one's jamming you at home.
Exactly, and I was going to say the other thing. So that's one thing, and the other thing is that what we're trying to do is to get the right information to the right place at the right time. And what the enemy is trying to do is make sure we get the wrong information at the wrong place at the wrong time, or some disinformation or other things like that. So if you take all that into account, that our adversaries are going to be looking at wherever the weak links are within that particular diagram, then that's what we need to try to deal with. So when I talk about system of systems in my following slide, then just think about that is a system of systems, because there are lots of individual systems that have been connected together for a military operation. Some may not have been connected together, and we need to link them back to headquarters here in the UK or elsewhere. So that's really the complexity that we're dealing with. So to put it another way, so modern military deployment for C4, which I mentioned earlier on, in a highly complex, highly dynamic system of systems environment is what we need to be able to deal with. And the fabric is really the networks and comms that I mentioned earlier on, the information system that enable that connection between all the different systems. Now, as I mentioned earlier on, adversaries already identified that. They're already targeting our systems in terms of our C4 capability, and they have the major investments that I mentioned earlier on. And the other thing is that they're doing things not themselves directly. It's not necessarily a state against state. That is very rare these days, but it's normally done through proxies. So you'll have other parts of the civil infrastructure organizations taking part in that or being exploited, this hybrid warfare concept where you can't delineate between the two. And the other thing I mentioned about the freedom of maneuver, and that's very much within the electromagnetic environment, because in the diagram that I showed you previously, a lot of the communications we do are done through electromagnetic means, whether it's the RF or some other means. So therefore, having some level of control of the electromagnetic environment is absolutely essential if you want to have that freedom of maneuver, and also to ensure that whatever we're doing is not unduly interfering with our allies in NATO or US or Five Eyes for that. So the catch from the catch-all from the program manager has been that S&T is critical to establish and maintain that advantage. And I think that's a no-brainer for most people to take on board. So what they've done is in the program is that these are the 6 key features that the program needs to deliver against. And I'm not going to read all of them, but essentially, in a nutshell, what we're trying to do is grow that C4 ecosystem within the UK, where we control those capabilities from industry, academia, our international colleagues within our own organization itself, and then grow that for the future so that we can have the generation after next capability in terms of our staff, in terms of our equipment and so forth. So it's an overall if I can say, it's an overall pipeline that we're trying to create, not in terms of the STEM capabilities in people, but the STEM capabilities in the systems that we're going to provide in generation after next. I hope that is clear. So the next few slides are going to be quite busy, so excuse me for that, but I'll give you an overview of what each of the projects underneath that program that I just talked about are actually aiming to achieve. So it'll be a very short snippet of the project, and then lots of detail on the slides, which probably in this room you won't be able to see. So in terms of the projects, At the very highest level, the C5I roadmap and concept. So this is C4 plus cyber and then plus information stroke intelligence. So what they're trying to do here, working with our stakeholders, the services, is look at the vision roadmap we need for science and technology integration into a convergence of those systems I showed in that very complicated diagram very earlier on. And the key part of that project is also how do we look at the future beyond line of sight capabilities that we need, RF gets jammed, etc. So are there better, newer ways that we can actually communicate beyond the line of sight? So that's the key thing they're doing. And in terms of the information data services, this is if you're sort of systems people, I'm essentially looking at a layered system now. So showing you at a very high level, we need to have that roadmap, direction, concepts that we're working towards. At the next level down, of the services that we need to provide, how can we define, design, develop the architectures that we need in the future, which can provide resilient data services? Very much, with your phone, you can get a service that you want, and we're trying to do exactly the same, but in a military context. The third project is looking at the next level down, which is what does the network infrastructure and the services within that need to be able to support the higher level information and data services. So we're looking again, developing the future architectures and the resilient networks you need to make sure that if you want resilient services, you can't have resilient services without having a resilient network. So what are the architectures for that? They're not different architectures. We're looking again at layers of the architecture that you want to develop so you can integrate them together at the end. The fourth one is about the next level down, which is the bearers and the transmission environment you're working in. So we need to be able to send, the messages finally that we want to communicate out. So what are the bearers that we need to look at for the future, which are novel, can adapt to the environment? I mentioned the electromagnetic environment is very complex. It can be. We have the underwater environment is very complex as well. We have the space environment, and adding to that, we have adversaries always try to manipulate those environments. So what is it that we can do to develop novel adaptive bearers which can actually deal with those changes to the environment or the waveforms that are needed? And the comms and network capability, this is more the people's bit. I mentioned the STEM capability earlier on. This is very much in that particular area. How do we invest in the CNN capability that we need to grow the capability in industry, academia, government, etc., and then our international colleagues through collaboration, PV ventures from companies, etc. How can we bring all that together to ensure that we have that capability that we need in terms of the S&T skills and expertise for the future? And the final one, the enhancement one, is the one I showed you very early on about the program area that we started this year, which is really looking at generation after next in enhancing our capabilities even further. So there's concepts like autonomous resilient architectures, is looking at the developments in AI machine learning that most of you are probably very familiar with from the news, but how can we exploit those inside our architectures so the architecture itself is automatically resilient? And that's a big challenging area. And then the other one is how do we develop communications against an evolving threat, which is obviously a continual challenge for us. So in the next 5 slides or so, I'm just going to go through the programs. I think I've used about 25-30 minutes.
Yeah, no, you're fine.
Okay, so this is just showing you the same thing again. All I want to point out is that they are actually a layered approach, data layer, network layer, and the bearer layer, and all the projects contribute either at the bottom level or the services that run on top, and the concept work wraps it all around, and the capability at the top should really be at the bottom is what underpins all that work for the future. So the first one, the roadmap and concepts, already mentioned that to you earlier on, but essentially the expected outcomes from this are with our stakeholders to have that roadmap and have the vision and the S&T roadmap, and then agree on the concept that consider to be critically important, working with our stakeholders, that we need to actually deliver to. And the other projects would then support the S&T development for that. So you can take, I'll leave the slide on for a few minutes longer so you can actually have a read of some of
They've got a
them.
copy of the slides, Mark.
Sorry?
They've got a copy, that's their computer.
Oh, they have, okay, yeah. And the future beyond line of sight is important in here because of the conceptual work is needed before you can actually develop the stuff. The enabling capability bit is the one I talked about the overall pipeline that we need. And this is very much working internationally, working at the national level with the UKRI, our academic colleagues and so forth, to how do we develop and maintain that scrap that we need in the supply base within our own organisation and elsewhere in that. The key thing that I didn't mention earlier on is the thread that runs through all the projects, and I'll use the political words about, saying it in 3 times. So it's experimentation, experimentation, experimentation. And the reason we need to learn from exploring and we need to learn from doing, that is the best source of developing our capabilities. So experimentation is an integral part of all the projects that I'm talking about, because you need to be able to try things out and see how you get on with them. So this one is the STEM pipeline. And then the autonomous resilient architecture I mentioned earlier on to you. This is the generation after next work. It's working very closely with both the US and our Five Eyes partners in looking at how we can have those adaptive architectures that are resilient in the future, drawing on machine learning and so forth as part of that. The other thing, which is perhaps not on here fully, is that we're also looking at the NATO level, at the future networks that NATO needs for its operation, and try to influence the thinking within that. Some of the acronyms you may need explanation for this sort of autonomous is the DDIL. It's really essentially in essence, is telling you why that complex diagram I showed you earlier on becomes complex for us, is the degraded, denied, interfered or interrupted low latency environments you're in. We need low latency, we need to be able to press something and get that message across somewhere else as fast as possible. And the other ones are self-explanatory in terms of adversaries trying to deny or degrade what we're trying to do and interrupt what we're trying to do. The deployed comms evolving against the threat. This is generation after next again. What this is trying to do is look at novel developments. First of all, in materials, we have now metamaterials which have very specific physical properties that we can manipulate and adjust, so they can be either, their response can be varied depending on the frequencies that are applied to them. So therefore, they're extremely useful for designing new antennas, very useful for designing protective materials that we might need to shield ourselves against very specific frequencies that they can be tuned to, and so forth. And then also looking at novel technologies from the wireless world, civil world. We have multiple input, multiple output beam steerable antennas, which are used for your mobile comms. We're looking at those for military use, as well as looking at how we can apply them to some of our networks for 5G, 6G and beyond type civil technology adoption. And then I'll come to my slide at the end about quantum. So we're really looking at what quantum communications can do for you, not only as a capability for us, but also what are the things that we need to do to defend ourselves against other adversaries using quantum type technology. The waveform development, the waveforms go hand in hand with radios, go hand in hand with appearance. These are, if you like, the workhorses that we need to ensure that when we're trying to connect different systems together, we have the right waveforms which can't be interfered with and so forth, so that we can assure that communication, as well as looking at collectives like swarms, etc., UAVs, and so forth. So there's a whole load of novel innovative work within this particular project, some delivered by universities, the Aberystwyth Spectrum Centre and so forth, and academic consortia that we developed, and also trying to understand how the threat may evolve as we go further in the future. So I mentioned the layers earlier on, so those are the layers that that particular project addresses. The resilient barriers and transmission, I mentioned about the fabric earlier on, and this is the stitching in the fabric, if you like, for that. This is also looking at the waveforms, which are, as I said, are core to all this sort of work, but then looking at all different sorts of communications that we can adopt, either to enhance the HF-NF communication we currently use, the VHF, UHF, but looking at some of the new developments that are taking place. So there's a lot of work on free space optical communications at the moment, because very difficult, obviously, to jam, but then we have all the other issues associated with transmission in the environment, acoustic communications undersea, but also looking at combining acoustic communications with optical communication, which is something which is really important, and lots of other things to go beyond the line of sight with novel developments. And the services one, finally, this is again generation after next, looking at mentioned AI and machine learning earlier on. This is very much trying to look at novel techniques that can maintain robust end-to-end network connectivity and deliver the information advantage. In other words, whether networks separate, combine, come together, whether you're doing it for a small platoon or whether you're doing it for a brigade and so forth, the ability to be able to adapt the network and its infrastructure and the architecture to address the particular requirements that you may have. And then in all of this, at the bottom is the ultra reliable, low latency stuff that we always want, and the high capacity that you always need, because there's more and more demand that people have for the sort of information services they want. And in part of the information services, one of the key ones most of you probably recognize is the imagery, video, which are really essential tools for the military these days. So we have a collaboration with the US looking at the future imagery standards that we can then get NATO to adopt. So we have that advantage, looking at the denied environments I mentioned earlier on as well. And in addition, working with the Open Geospatial Consortium, which is very much a civil development, looking at standards in the geospatial area. So that's a key one for us as well. And then looking at all the issues to do with information assurance within that network. And the information assurance is a key bit, because what we can't do is have our networks and infrastructure either denial of service or hacked in any way, and then that's an essential part. And hopefully the 4 diagrams or pictures to your right probably bring that across. So that was a quick canter, and I did warn you there, they're very busy slides. I didn't have time to take out some of the short things, brief things from it. So what I'm going to finish on is just a very quick dip into the emerging disruptive future. I was introduced as one of the people looking at disruptive technologies. That is very much what I do, and I just want to give you a flavour of what we're doing in quantum. It will be a flavour. I can't go into too much detail at this setting. So, a lot of people think quantum is a new revolution. No, it started at the turn of the last century. That was the first quantum revolution, when we had quantum mechanics, which was the theoretical underpinning that you needed to say that the quantum theories and all the other things physicists were developing were actually real and not just imaginary concepts which had no foundation in nature or in science. And those particular developments at the turn of the last century led to the development of transistors, as an example, lasers and so forth. So you're already seeing the benefit from that first technology revolution in quantum. So I'll class that as being disruptive. If you have TVs, you probably have OLEDs. If you're, one of the people who likes to keep up with modern developments and so forth, and that's a quantum technology. But really what I want to focus on is the second quantum revolution, which really is from 1990 onwards. And I class that as being disruptive because they are realizing new materials, new technologies in that area, and obviously the mathematics improves over time as well. And the key thing to take away here is that probably most of you are aware that in quantum information processing, the fundamental unit isn't a bit, but is a qubit, whereas in our digital world, it's a digital bit, which can be a naught or a one. And the thing is, in a quantum qubit, and this is one of the spooky things about quantum, if you like, you can either be naught or one or both at the same time. So this is where the power of quantum computing and information processing comes in. So if you only have the digital bits, you have essentially n squared registers. If you have qubits, you already have 2 to the n registers. So it doesn't take much imagination that this is an exponential where, if you have 300 qubits shown at the bottom, you're exceeding the number of atoms in the universe. But that's essentially the nature of quantum information processing, is this additional capability boost that you get from using quantum information processing on computers. And that's why it's always been put forward as something that would actually, hack into our systems and therefore decrypt our encryption codes, which is obviously quite an important thing. But there are more other uses for that. But the challenge is, I've described what they are, but it's very difficult to understand how to program them and so forth, which I'll explain in the next slide. So you saw the very complicated diagram I showed you very earlier on about the military operations that we have to deal with. This is just a reduced form of that. And the key thing that I want to bring out in that is that in terms of quantum, the superpositions I mentioned earlier on, or perhaps didn't mention, the entanglement, they offer unprecedented sensitivity, which is really offered by the coherence that you get in quantum states. And that is a game changer for lots of applications. So position navigation and timing. We know if we're in a GPS denied environment, we need to have accurate timing between all our systems. Now, how are we going to provide that? So that's a potential solution that you get from quantum clocks, as an example. They are being used already. Then in terms of quantum sensing, imaging and ranging, that level of sensitivity is unprecedented. We already have gravitational detectors which can monitor very slight changes in gravity, which we can then use to detect things which are either underwater, as an example, or elsewhere. So those are the things. But one of the challenges that offers is this sensitivity and the coherence is also the challenge that we have, because it's very easy to decohere. You can't maintain those states as an entanglement for very much longer, needs lots of different engineering skills and so forth. So that's an opportunity for quantum computing, but also a potential issue. And then the other thing is led to now a growth in development of quantum safe cryptos and so forth. So there's another, development as part of that. The application would be in any of these areas here. Now, I wanted to just show, I think, a couple of slides just to finish off on there. I don't know how, can you read that at the back? So the thing on the left, the UK has been very good in detecting this emerging technology a number of years ago. A huge amount of investment has gone in. So we have a UK National Quantum Computer Centre being set up in Harwell, which will be online this year and will be operational next. So we have been doing really very, very well, pulling well above our weight. So the thing on the left is very much about the S&T level. So you can see from the number of publications, which is the second column, the UK is doing really well. So we publish, we're number 2 in the ranking of that. Our funding is not at the same level as USA or Germany, but nevertheless, we're punching well above our weight. And where we're doing exceptionally well, if you look at the diagram on the right, which is about generating new startups, new innovative companies, and we're really doing extremely well in that particular area. You can see that we're ranked in terms of number of new startup, number 2. But the point I wanted to make, and some of the UK companies, I mentioned in the diagram, in the images below, is that China, which has been lagging in terms of its scientific output, publications, etc., is lagging in terms of new startup, has had a huge investment in this area now. So we're beginning, these reports are from McKinsey, so there's a little bit of, these are estimates really. So, sorry, let me go back, I haven't got that slide here. So that is a key threat. And I mentioned right earlier on that S&T is an international competition now, who can be at the forefront, developing the technologies, get them into your system. And the rise of China in this particular area is a real worry for all of us in the government. How do we contend with the level of investment they're making and so forth? And obviously it's not an open country, so you can't actually find out enough about it. So the final slide is we have invested, we've got this thing called, it's a UK company called Orca. They have this photonic computer, the quantum computer that we already have. We're playing with it, we're using it, and so forth. So I won't go into technical details, but the applications for that quantum processing, I mentioned that 2 to the qubit, the number of qubit type processing power you have. There's lots of areas where that parallel processing at that magnitude would be really useful. So image classification is an obvious one. Modeling is another one that some of the industry work in pharmaceuticals are already looking at. Optimization, the QUBO is just a quadrified, unconstrained binary optimization. So in other words, traveling salesman type problem, which is very difficult, or a logistics problem where you want to work out, what level of goods you want to distribute where, and what's the most efficient way for doing it, using less fuel, etc., etc. Logistics, so lots of different applications. NLP is natural language processing, which is a highly parallel task. And the final one is that with the rise of AI and machine learning, the neural networks, NNs at the bottom, then we need to look at quantum in relation to traditional technologies, the digital technologies, and we think we need a hybrid approach where it's a horses for courses. So for quantum, you use quantum computing with digital computing and get the best out of each and make sure they can work essentially together. So I think that's my whistle-stop tour on all our work. And we have one more slide, which I will show. And this is about what our engagement should be with your virtual company. And Paul and Eric and others and Kieran have drawn this one up. So I'll leave these up. These are the sort of discussion points that we can actually talk about later on today, if you like. So I think I'd like to finish there, and thank you very much for your patience. I apologize, the last 5 slides are a little bit busier than I expected, but I hope that gives you a flavour of what we do in defence science and technology, working with others, both nationally and internationally. So,
thanks, Bob. Right, questions?
First of all, thank you very much. That was really fascinating. We read a lot of things in newspapers, and I'm well aware of the things that when I do understand what's been written in newspapers, I realise that they usually don't know what they're talking about. But when we hear about the threats to defence, whether it be undersea cables being cut, whether it be electromagnetic pulse taking out all of our infrastructure in one go, whether it be Huawei being in the edge of our communications networks, I mean, how many of those are really serious threats that we don't have mitigation for? Or how much of that is you guys just bringing it up there so that you can get some more funding to or disinformation to the enemy? I don't know.
But I think they're all threats, and some are beyond what S&T Lab ourselves can do. The cable cutting that you talked about is very much, these things are monitored, but if a nation wants to deliberately do that and even hurt some of their own infrastructure as a result, that's something they could do. But there are measures in place to give you that, if you like, not sort of failure mode, if you like, or some level of resilience that you still have within the system. So I think those things, the resilience we can deal with. The cable cutting, other than people observing and monitoring, etc., it isn't something that we do. And in terms of industry, and that's a big worry because everything is quite complex these days in terms of all the layers that I talked about, in terms of communication, the bearers, etc. So you really need to be mindful of who is providing which part of that system. And so that is something that we would look at as part of our research work in terms of where, and also obviously from our own side, we have an offensive capability, and I'll say that in inverted commas, but we need to be mindful of what we can do and what others can do to us. So the international scene you have to deal with very, very carefully at the political level. So S&T, yes, it's a worry.
It's a bit like informing government, so a bit like after 9/11, the infrastructure, everyone thought service delivery was a given. I had to approach, I was in the military at the time, BT at the time, and say, what happens if we lost London? And they said, oh, everything's still being rerouted. Like, imagine some big giant coming along, just put a shovel and uplifted London. So we kind of, through the military and analysis through Dstl, enabled industry to redirect, to make their networks more resilient in support of industry. It's not just military we support, it's the government as well. That's what's got to come through. So when identifying these threats, we then provide options for resilience, don't we? And how that can be done. And push the government to push industry to say you need to do better in these areas. Otherwise it could be undermine our economic capability this way.
It's about scenario planning, isn't it? But have you got the right scenarios? And I guess the professor's work helps us to envisage whether we're actually thinking of the right questions, so we can then really test whether.
Do you know where your data's going, during the day and during the night time?
I spent most of my career building trading systems. So I'm
Yeah.
thinking of that threat, for example, and I don't think that the industry is
No, I
that
agree.
resilient in that respect. And in fact, I was working opposite Twin Towers when putting a new system in underneath when they came down. So that took out a massive hub of network cabling that all went under the World Trade Center. So yeah, some banks, they could just switch over. JP Morgan could switch straight to Bournemouth and no trouble. They were up and running the next day. Other banks not so clever. Yeah.
Yes, I think as Paul said, we have the concept development as a key part of looking at some of the different scenarios, concepts that you need to be able to deal with, and but you need to work cross government because some of the things are not within our remit and some of the things are. But you need to have resilience being the key thing, and from local things when something happens, the delays and the disruption that causes, and we can't have that for our military systems. So if someone wants to do something, push the button, we need to make sure that button works.
But how easy is it to operate across government? I mean, when I was working in government a long time ago, they were talking about joining it up, but I don't think they have. And I think COVID has made it worse.
I think being S&T people, I think we probably find it much easier at the levels at least I work with. So I think science and technology people are willing to collaborate, discuss, and then move things further forward. I think the challenge as always comes when you start talking about money, and that's where issues normally start about, who's got funding for what. And
there are no politicians in the room, Chair. The hardest bit about cross-government working is the politicians. If you let the people who actually do the business do the business, then it's
so it's okay. It's only when it comes to money and so forth, and
And do you look up the strategy online? There's the multi-domain integration strategy that came out 2 years ago. And that's about mainly about the MOD, Foreign Commonwealth Office, Home Office working closely together. You can see that both ways. So is that more about saving money? So if the Home Office do better cyber than the MOD, then stop all the MOD doing cyber? Or is it about us just working closer together? It could be a bit of both. But we are starting to write strategy for it, I think, better.
Maybe not links, the links with Home Office have really been very strong. Links with the security services are very, very strong. It's some of the other departments, perhaps it's a little bit. Anyway, we're there as a government S&T lab, so we service the urgent needs from wherever they come.
You mentioned earlier about lack of skills in the STEM area. Sorry, you mentioned earlier about the lack of skills in the STEM. What's being done to address that?
I think Paul may have a little bit, but for myself, I reach out more to my academic colleagues, and I'll say this because I've also run the diversity thing within our within Dstl. One of the challenges that we have, and I'll give you some stats from the Royal Society, about 30% of UK nationals who are from a BAME background coming out of our, 30% of UK national people of BAME background are coming out of our university with STEM background. In other words, doing STEM subject, 30%. At PhDs, 25%.
Yep.
And in Dstl, we have like 1.5%. So my thing is going out to the universities, there are many in the UK, reaching out to the ones that are not aware of Dstl, for example, and also are okay working in defence and security. We are very much doing defence. We're not doing offensive work per se. So trying to attract those as one example. The other one is the graduate fairs and so forth, is really getting that front end of the pipeline populated first to be able to take that all the way through. So that's something for my...
Yeah, so the bottom line up front, it's the nature of our culture across the UK. And from a technology perspective, I'm sorry to say this, British nationalities are lazy when you get to university. So STEM's doing very well. GCSE, O-levels, 100%, A-levels, 100%. But as you move out into the higher education, as Bob was saying there, only 47% of our universities are filled by UK nationals. And we want to maintain UK nationality here. And then for certain organisations, particularly ours, you've got to be British national. And we have issues working with, we have to kind of Chinese firewall into universities, research, keep it official, and then bring it in through British nationals into the military or into the Home Office of the SEO. We have that big problem. And then
that's Chinese literal and
yes, but we have we have a very good comms and networking course run by the Edinburgh University, and it's only something like 10% filled by UK. It's mainly by the Asians that turn up and come and take that course. Pakistan, India, very big fillers of this doing this, and then also culturally. We see this as kind of being geeky still, whereas a network engineer, the caste status from India and Pakistan is seen up there with as a banker, a doctor, all that sort of thing, a professional. Whereas over here, we still haven't grasped that kind of idea. And in the military, particularly in military background myself, it's guns, missiles, airplanes, and all that. Oh, comms gone down. Oh, let's go and give comms a good kicking. And we get a good kicking for like 15 seconds, get it working again. And then they'll shout and go, I need a better network. They're out there doing guns, because that's exciting. And that seems to be a lot of the British attitude. So it comes to that. And we're trying to push that. And that's the bit we're trying to do is trying to get that message on the technology through. But maybe, as an old politician said many years ago, which you all know, probably I think it's Margaret Thatcher, we're a nation of shopkeepers. We're service providers. We're not actually doers, are we? I don't know. Or do we just need to change that culture? And how do we change that? And that's probably where we would like to work with you in building up some of this core ability in higher education. That's where we have the problem. And that's where we're trying to get.
There's also a drain into the high-tech industry. They're very much wanting these people, all the areas I've been talking about are really civil technology areas, so in the salaries that they're offering graduates to start within their organizations are really very, very attractive. So when you're a youngster trying to tell them to come and do exciting stuff for government and have international travel, work with colleagues, etc., have good pension potentially at the moment, it's a difficult thing when they're being offered maybe 70, 80 grand to start off with a high-tech.
And we're starting to go into that technology leap with the lower, non-geospatial satellites coming online, software-defined slicing, software-defined networking, datering, and 5G's coming on with forum this afternoon with that. And then to take that from a basic, when I was a basic radio operator 35 years ago, of analog, two pieces talking to each other line to line. Now we're into, I can guarantee you a slice across the network, across between your CPU, through to your data, over how many bearers and all that. It's just exponentially gone up, hasn't it? What do you say here? That whole raise of how we do business is a leap. And I don't think we're kind of, a lot of the youth, and you can't leave all of them, still see, just see that as working, but don't understand what's behind it. We seem to have lost what's behind it.
Just wanted to say your quote, by the way, didn't come from Maggie Thatcher, because she was a shopkeeper.
Oh, that was it, yeah.
It was actually Napoleon.
There we go then, Napoleon, there we go then.
What happened to him, yes.
Thank you for that one.
Just as a counterpoint to that, so we don't go out of the room thinking, God, all our kids aren't interested. My son's 9 years old, the most overscribed out of school club was coding, way above football.
Cyber we are good at, cyber we are getting good at, but it's not cyber, it's waveforms.
Yeah,
Networks.
have we lost a bit of innovation? I mean, I think, you know, a lot of modern day computing stuff for all of us of a certain age, I think we're all of a certain age, we kind of grew up with that innovation. It was all new. Britain was kind of at the leading edge of microprocessor innovation and, you know, obviously a lot of
Spectrum, BBC Computer. all
yeah,
that.
exactly.
Yeah.
You know, Sinclair and so on. So a lot of that modern computing was born in that kind of post-Second World War innovation age. And have we lost a bit of that as a nation? Are we too reliant on other countries to do that innovation, and we're just consumers of that, and we're lacking the people who can? Because I think what you're saying about the skills is very much based on a definition of what are the skills that are in demand, like AI and machine learning and so on, rather than saying, but what's the generation after next of
If I could
technology?
chuck something on the back of
Yeah,
that.
do.
BBC Micro Spectrum turned up, was in school by the early to mid 80s. The ability to you know, and your second to last bullet point, non-traditional defence suppliers. You know, I think the point was made over there about, you know, sort of young kids going into fintech because it's accessible. The number of people who are exposed to that kind of thing, you know, from the creation of the computer to computers being in school on the desk.
Yeah.
Yep. The ability to take the sort of evolutions of fintech coming out, what people are doing with it, and then to transpose it into defence suppliers. It's the same crowd, you know, you did the picture up earlier on of who the big primes are. How are we approaching the ability to take the real innovation that's going on elsewhere in IT, comms, connectivity, and then somehow bleed that through? I think Dstl call it the Valley of Death,
Well,
where it's been created,
it's
but
the
it's
Valley
not been
It's
exploited.
the Valley of Death, it's also the that non-traditional. So when I was at a presentation in Tottenham in one white lines the other week, it's the terminology. The military and the MOD use certain terminology, and they were given a presentation, and I was like translating in my head, going, "That is zero tech. That is zero technology. We want that." That's I said, what controller? You know what the word controller was, you know. So there was it's a language thing as well. So people are doing it, they don't know they're doing it. But however, to get into the military and to support the military, it's not that big of money anymore, is it?
No, we have the accelerator, defence accelerator, which is looking for innovative calls, proposals from industry SMEs that haven't been involved, and that's really proving quite useful as well. But often industry do propose something, and that's proposed very much as a product they already have, and then you say, well, that's your product, but when you put it into
before
defence,
you come as a supplier, how many of your team are vetted?
Yeah, but if the vetting is less important in this initial round, which is really trying to make them understand what the military problem actually is, and the ones who get it, they come up with some really good solutions. We have a number that were presented the other day at our presentation from industry. These are small companies doing security sector, so it is starting, but it could do better. But maybe the the financial world maybe pays a lot more for these developments. I don't know.
I think one world that you could actually tap into is gaming.
Yeah.
I mean, the gaming world and the UK is a world leader in gaming.
Yeah.
We have extraordinary capability. And the same with media.
Yeah.
You know, the way in which media manipulation, I mean, CGI, etc. These are people dealing with physics in a way which you know, ordinary computing doesn't deal with.
Yeah,
and that's how we got into the intelligence stream in Afghanistan. We looked at how the pornographic industry was doing. They were streaming that. And we said, how do we use this? And we took over a network there, which the army were using to move around illicit videos, and we labelled it secret and called it Priscilla and said, that's now our intelligence network.
Well, the truth is, where is all the is you know, technology advances come? I'm sorry to say, through pornography, gambling, gaming. You know, these are places where sort of our human traits, negative traits potentially.
Well, there's money.
No, there's a lot of money in them, and people are attracted to them, and it's an arms race in a different way.
So the way the expertise in that, my son-in-law is a director of a games company. He's an artist, so he's very good at. So they're moving up in that innovative ideas, etc. But the bulk of the engineering work in terms of coding goes elsewhere because they can get it cheaper from somewhere else. So you're right, we need to draw on those, but you need to draw on the coding skills as well because
We have coders coming in, so Kieran's a software, programmer, etc. And then, so I know how to integrate some stuff. I need to go to somebody I can trust and say, build me the control on the edge of this network to talk with this antenna or talk with this waveform. And that's the bit we're lacking.
But I think what you're all right about is we need to get that pipeline from junior school upwards, and the Raspberry Pi. Someone mentioned Pi VC Mike, but I was involved in many years ago. But then we have the Raspberry Pi as well that people play around with, and that's proving to be really useful to get schools and other people involved.
It's a generational shift, and it's a cultural generational shift, and generations, by the way, about 22 years.
Yeah.
So we're not solving today's problem today.
Yeah.
It's actually we're solving tomorrow's problem for the things we do today.
Yeah, and the technology that we're solving is evolving at a much faster rate as well. So you've got the generation after next has that problem as well, that you've got to deal with what the technology evolution, science evolution is in that time as well. So it's exciting but challenging areas.
I think maybe one of the other challenges we're going to look at is actually how do we optimize the talent we have?
Yeah.
We can't always complain, hey, we haven't got enough or we're not
the
doing
reskilling.
So therefore, how can we actually optimize what we've actually got and really make it work harder for us?
Yeah, and I think that's the model we need to start doing, is sponsoring people come through and understand they may come cut their teeth in Dstl like Kieran will. You might leave in 3 or 4 years, go to industry, but then come back to us or come back into the MOD or come back into the government somehow in 10 years' time and then maybe leave again. And that continuous joining Dstl for life shouldn't happen anymore. Or joining them, that's the changing. I think my brother-in-law's a quality engineer, and he changes jobs every 3 or 4 years just to build up his CV, move around, and for diversity. And I think we probably might to do that. How do you track and tag those? So once he's got that security clearance, I know he hasn't gone off and got dirty somewhere. Bring him back again.
About 50 years ago, when I joined the General Post Office, and a lot of my friends joined Aquila, they were all thousands of apprentices in the UK. And most of those good people were poached by photocopying companies, HP, Harris, various other IT
But that's not
organisations.
bad though. because
And
you build
that fed the
You fed
system.
it.
But when the apprenticeships died, the IT industry, and I've been in it for 50 years, they never trained anybody.
Yeah.
They stole everybody.
Yeah.
All their lives.
Oven ready.
And
Oven
yeah,
ready.
all of it was the same. But there was no feeder. Once you got the apprenticeships out of the way, there
So
was
there's
no
almost a
feeder.
thing
There's
there on
nobody to
the-
steal from anybody.
Does the government do a lost leader of that again? I don't know, but we probably can't afford to invest in that anymore.
I was going to ask you a
but-
question. Have you got do you sponsor graduates or run apprenticeship schemes?
We do both. We have sponsored A-level students coming in, and when they go to university, we have some of them working with us. We have apprenticeships going on at the moment. We have like 100 PhDs, etc., which obviously have to be UK/EU nationals. So that's another source of supporting academia and that STEM development. So yeah, we're doing all those.
We make use of the BIS, British Indian, I can't remember what it stands for. 8 billion coming out from government through the BIS into the UK Research Institute, into research councils. They'll set up big themes and we help direct those themes of what we want to look at next generation. And then for every bit, like if they invest 8 million into something, or if we invest 2 million into something, they'll come in and say, we'll double that. So we'll kind of work together closely on that investment. So
Just
we're
some of
trying-
us are
But
involved in some of
what
those
you're
schemes.
losing is the talent, because I mean, my brothers both went to university. Academics, they're useless. What you're not getting is you're not getting the engineers like I was 50 years ago, and the telegram engineers and the photocopying engineers, those who had actual talent and that developed into being really good technologists. You're missing that bit because there isn't a proper apprenticeship scheme at ground level. Academics are great, but you need the real down to earth.
That's a cultural
Yeah.
problem
Yeah.
because 10 years ago I worked in the Sector Skills Council for IT, and we ran the apprenticeships program before it became apprenticeships it is now. and we could not get people through the door. Like kids just couldn't care less. They were like, that's blue collar, that's beneath me, I don't want to do it. And there's the mindset change, right? It's cultural, it's entirely cultural. So back when you're talking about 50 years ago, maybe it was quite an attractive route. These kids, they all wanted to go on a bender at university and spend all of mum and dad's money getting drunk and then go and get some high-flying job in marketing. They had zero interest in what we were trying to push, which was
you're probably affecting it on children.
it could
It's an interesting thing about how
it's going to take a
teaching
generation to come
professionals.
back.
And there's a thing called Teach First, right, which is where they're looking to take people out of university, 2 years teaching, and then they go and do something else. And then there's another organisation which is actually looking at effectively Teach Last. You know, sort of people in their probably late 40s and their 50s who've been through. They may have got a bit of money, you know, they're well set up, and they've got a lot of talent, a lot of knowledge, and they want to go back. They go into teaching at that point. And maybe, you know, from a lot of the stuff you're actually doing, you might be able to tap into organisations, people who are probably in their 50s. They're not going to go any further in their organisation. They love the deep technology stuff that they're doing. Pretty smart people.
I agree. I mean, we've got
bring them in late.
We're non-ages, so in terms of our application, we really invite applications from
I've come
people
out
from all
35 years in the
backgrounds.
Navy and joined Dstl, so yeah, because that's the way. But and then the military are doing that. They will the teaching authorities will fast track military people coming out.
Okay.
It's just it's the military. Some of them want to do it. Half of us probably don't want to do it, or got the right skill sets to teach, not the right skill sets for empathy and sympathy. Maybe that's probably the correct way to put it.
Is there a reservist type thing we could actually generate? You know, because getting an expert reservist out of, I don't know, Google or whatever can do 20 days a year. That would be phenomenal.
That's a bit like the cyber reserves, That's something.
We do that already.
Brigade or something.
Yeah.
I sort of feel we've strayed a little bit away from.
Yes, we have.
Apologies.
No, it's all right. No, it's been a useful discussion, but I thought I might just bring us back. Is there one last question before we sort of start winding things down?
Do you want to walking us through that list a little bit?
Well, I think that's left for us to think about in terms of what we, the STL and the company do in the future, and I got a copy of that slide. Actually, there was one
and is
question.
it worth us
sorry, can I
affiliating, etc.? Yeah, that's what we are here to discuss later.
Yes. Your slides, some of them have got classifications on them. Can we?
I think all the slides are UK official, which means you're okay to share within this particular.
So you wouldn't want us to put them on the website?
No, I prefer them wouldn't go on the website, but you're more than happy to use them within your fellowship. That'd be fine.
As long as I know where we stand on
I
that.
think Paul can come back to you about most of them were taken from the presentation that we're given to industry and other people about the research programs to get that, submissions of interesting, innovative ideas. So Paul can come back to you about the overall, but I prefer if it's kept within your.
Those ones we like. If you want something on the website, I can redact some of the information out of that. I don't have to
I think that would be useful.
And any point of contact, John's got my email address, so we can do all that.
Can I ask one question, Professor? I am actually a military guy.
I thought you were,
Yeah, and in terms of, you're thinking about the generation after next.
Yeah.
Is the one thing that you've looked at in the generation after next that we need to worry about now in like today's or the next generation that worries you most?
Gosh, what a difficult question.
Well, what I'm going to suggest is to give you 5 minutes to think about this.
Yeah.
Because we're going to break and have an opportunity to have a drink.
Cool.
And so I suggest you get the answer to that one in a minute.
I've got a few for him, but. So one of the big things for us is assurance. So most of our stuff is critical in some shape or form, might be safety. So there's a lot of algorithms that are beginning to be put into systems, machine learning, etc. And trying to assure those and validate and verify them is a really big challenge because they will just gradually seamlessly appear everywhere. And you're not sure what level of assurance the people providing the systems, actually providing for that and whether it will pass muster. So that's one key area for us is assuring that. I think that's
a good one.
I've got one on this, carry on.
I think out of amazing presentation, by the way. How you managed to get all that information across in what was 30 minutes was incredible.
We've done this before.
I'd also like to say, I work on the E7 program at the moment. It's the program manager for the RAF, and we get some amazing Dstl support. So thank you very much. And the person who supports us particularly with is Andy Robertson, who you may well know. So thanks very much for a starter. I think the most important two words on the presentation are actually in the bottom left: team building. I think that's where we need to be most open. I think we probably need to challenge ourselves as well in terms of how we build our team, because many of us go out there and go, this is what we're looking for, this is what we want. We should now start thinking, let's start looking at what we don't want, because they're probably the people of the future, actually, when you look at it. And in a military sense, that's your long haired, tattoos, massive beards, 3/4 trousers and sandals. Like, which is totally not military, but they're the people we might want. They're all in this skill. They are, most of them. That's a real takeaway for me, so thank you.
Okay, I think that's a good point to draw these bits of the proceedings to a close. I'm going to ask Master Rob now just to say a few words of thanks to our speaker. I think he's going to say a few words just about the company for the benefit of those of you who are not familiar with it.
Thank you. That's, as you said, actually, you took the words out of my mouth in a sense. That was an extraordinary presentation. I've learned an awful lot, and I'm also trying to decipher all the acronyms as well.
I'll do that when we do that. That's my fault, sorry.
Sort of any presentation like this, you just sort of glossary running along the bottom.
Yeah, we normally put that, but I didn't have an opportunity to do that this time. They're not on my slides, unfortunately. So.
Yeah, and I just, it's also the generosity in sharing this with us, and that's really important because we're on your side. I mean, to be honest, WCIT is the philanthropic side of the tech sector, and that doesn't mean we're not in business. It actually means that we're actually aiming to do good with IT, and we're trying to promote the use of IT to do good, and we do that in a variety of different ways. I mean, we've got over 25 different groups, and the government panel is but one, and we have many others, and our affiliations with the armed forces and with professional and trade organisations, because we have to make that connection. For those of you who don't actually understand, we're a city livery company, but our influence extends beyond the city of London, across the UK, and we have connections around the world as well. So that's one of the things that is quite important for us. And we really do value the links with the armed forces and agencies within the armed forces. We have relatively, or hopefully very good links with the Royal Signals. Now we have with HMS Collingwood through John, and I believe we're also hoping to build some relationships with the RAF as well. I mean, there is and we would love to find a way in which we could develop relationships with Dstl. Because things you've actually put down here are what we're about. It's about an exchange of information. It's about you mentioned team building. It's about people coming together and sharing ideas and connections. Things happen through that kind of serendipity, as well as just something being structured as well. So I also want to say thank you again.